So what we're going to look at today is Introduction to Trigonometric Functions. And we're going to think about unit circles. I've given you a copy of this unit circle, and it should help you for a start. All right? Have a look at the unit circle. Bring it out in front of you. We'll go through it and talk to you. I will talk through it as well. All right? If you've got a unit circle, pen out. Now, objective for the day. You should be able to redefine sine, cosine, and tangent as functions of the unit circle. All right? Functions of the unit circle, that's important. And identify the periodicity of the functions. It will bring me to the idea of amplitude, period, and equilibrium. All right? Now, you should be able to map the revolution of the unit circle to an xy plane, where x is the argument over an extended domain. So you are going from x to 0 to infinity, plus or minus. And then identify the standard amplitude and period of the sine, cosine, and tangent functions. Yep. All right, I'll give it to you. If you haven't got it, I should have spare. All right, let's keep going. Next, yes? Of course. I've got spares. I always have spares of unit circle. All right, next. Now, let's think about the definition of sine, cosine, and tangent using the unit circle. Sine theta is the relationship of the vertical. That is the height of the point on the circle from the origin compared to 1, which is y. So think about it with Pythagoras' theorem. Sine theta is opposite over hypotenuse. The hypotenuse is the radius, which is 1. And the height is y. Y over 1 is sine theta. Cos theta, horizontal. The width of the point on the circle from the origin compared to 1. So here, you know this is x. You know this is y. Cos is adjacent over hypotenuse. Therefore, x is cos theta. Sine theta is opposite over hypotenuse. So that's y. Because r is 1. The hypotenuse is 1. We don't normally write 1. And then tangent theta is the gradient of the radius or the gradient of the line segment that's perpendicular to the actual tangent. Which means we have the slope. Tan theta is sine over cos, or y over x. Alright? Everybody recall that? Yeah? Using unison. Very good, thank you. So now, we also bring in the idea of CASI. Cosine is positive here. Everything is positive there. Sine is positive, and tangent is positive there. Why? Because over here, all the y value is positive, but x is negative. Both x and y, negative. So y divided by x is positive. Here, all the x is positive. Therefore, cos is positive. Correct? Now, you also know the Pythagorean trigonometry identity, which is cos squared theta plus sine squared theta equals 1. Alright? X squared plus y squared equals to r squared. Yeah? Pythagoras theorem. Aiden? Laptop? Alright. Close it completely, please. So, next. Now, some trig identity we have looked at so far. We know tangent is rise over run, is sine theta over cos theta. And then the parity, odd or even identities. Sine theta equals to minus sine theta. Tangent minus theta equals to minus tan theta. Whereas even, cos minus theta equals to cos theta. So think about it, if you're moving measuring angle, cos minus theta is coming this way. If this is theta, this is minus theta. Think about it. Cos is positive. Correct? So therefore, cos of minus theta is the same as cos theta. Whereas, think about it, if it is sine and tan. Coming down here, theta, theta, that is minus theta. Sine is negative and tan is negative. So therefore, sine minus theta is minus sine theta. Tan minus theta is minus tan theta. Whereas cos minus theta is cos theta. Alright? Let's move on. Now, can you therefore evaluate these three in terms, these 6 or 5 actually, in terms of degrees? What is sine minus theta? 30 degrees, sorry. Thank you. Negative sine 30 degrees. Which is, what is sine 30? What is sine 30? Half, thank you. So therefore it's minus half. Alright, what about cos minus 60? Is it plus or minus now? Plus. Cos 60 degrees. So therefore is half, thank you. Now, tangent of minus 45 minus sine minus 30 plus cos of minus 60. So how are you going to do that? What is tangent of minus 45 degrees? Negative. Let's write down first. Tangent 45 degrees. Alright? Now, sine minus 30 degrees is minus sine 30 degrees, correct? Yeah? And cos minus 60 is same as cos 60 degrees. The reason I'm writing down this is you know minus and minus will give you positive. Alright? So therefore, you've got minus 1 plus half, which equals to 0. Now, in terms of radians, start thinking about something like minus sine pi. Minus cos minus pi over 3 minus tan minus 2 pi. Alright, same thing apply. Sine pi, let's leave it as sine pi. Alright, now here, cos minus theta is the same as cos theta. So therefore that's cos pi over 3. And then that will be minus will be plus, correct? Yeah. Thank you. Tan 2 pi. Alright, sine pi is 0. Cos pi is half. Tan 2 pi is 0. So therefore that is minus half. Alright, how are you going to do the next one? You've got sort of, it looks something like the Pythagorean trig identity. What we need to do, what I'm going to do is show you something. Let's do this on the side. Cos square minus pi over 4 is actually the same as cos minus pi over 4 times cos minus pi over 4. Alright? Since we know that cos minus pi over 4 is cos pi over 4 times, therefore this expression is equal to cos pi over 4 times cos pi over 4, which is cos square pi over 4. So now substitute in. Here you will therefore get sine square pi over 4 plus cos square pi over 4. So therefore that equals to 1. The Pythagorean trig identity. Alright? Happy with that? So you must remember sine square pi over 4 is just sine pi over 4 times sine pi over 4. It's just a convention we use. Alright? And then cos square of minus pi over 4 is actually cos minus pi over 4 times cos minus pi over 4, which is cos square pi over 4. Happy with that? I'll move on. Alright, yep.
How can cos squared minus pi over 4 be the same as cos squared positive?
Alright, think about the, let's go back to the go back to the unit circle. Everything is positive here, everything is negative there. Its cos is positive here, correct? Yeah? So if this is theta, measuring angle, this is minus theta, correct? So here, cos theta equals to something. Cos minus theta, this, because cos is positive, therefore, this is the same as cos theta.
Yes.
All right?
Yeah.
Make sense? All right, good. So next, now, complementary identity. Sine of pi minus 2 theta equals to cos theta. So if we know that this is theta, 90 degrees minus theta, all right, you know that this is theta as well. So theta plus 90 degrees minus theta. All right, oops, wrong. I'm just going to redo that. So let's clear that. Let's do it again. This is theta. All right. So 90 degrees minus theta will be that. Agree? Yeah? So you know, therefore, if I use 30 degrees to prove it to you. This is 60. This is 30. So I've got 1, 2, and square root of 3. Sine 30 is half, and cos 30, which cos 60 is half. And 60 is actually equals to 90 minus 30 degrees, or pi over 2 minus pi over 6. All right? Can you see that? So remember, sine pi over 2 minus theta, 90 degrees minus theta equals to cos theta. Cos of pi over 2 minus theta, 90 degrees minus theta is the sine theta. Supplementary identity. Supplementary identity, if this is theta, all right, this would be pi minus theta, or 180 degrees minus theta, right? And you know that the reference angle will be theta here. Yeah? Remember, your reference angle will be here. So therefore, sine pi minus theta is the same as sine theta. Same, this is where the quadrant is. Sine will be positive. And then cos pi minus theta is in second quadrant, therefore it's minus cos theta, and tan pi minus theta is minus tan theta. All right? So the complementary identities and supplementary identities, you should recall. Now, can you evaluate then in degrees sine 390 degrees? How would you do that? Couple of ways of doing it. You can, if you like, graph it. So you start from here, 360, and here, that is 390 degrees. So you therefore, you know that this is sine 360 degrees minus 30 degrees. 390 degrees. So therefore, 390 minus 330. What am I doing? It's 390 minus 330. Minus 360 degrees, therefore it's sine 30 degrees, which is half. Correct? It's not negative because you've gone around in one rotation and back to the first quadrant. What about cos 210 degrees? Which quadrant would it be? If I go around here, what quadrant would it be? Second quadrant, right? So let me sketch it for you. I like to sketch it so that you can see what I'm doing. So I'm start from the x, positive x-axis, measure 210 degrees, 180. So that's 200 and minus 210 degrees. All right? So is cos positive or negative here? Negative. So therefore, this is equals to, you know that is 210 minus 30 degrees is minus cos, minus 180 degrees. Cos 210 degrees minus 180 degrees. So therefore is minus cos 30 degrees, which is minus square root of 3 over 2. What about 765 degrees? Thank you. Because this is tangent of 720 degrees plus 45 degrees. Because you have done 2 rotation. And then back to 45 degrees. So therefore, that is tan 45 degrees, which is 1. If you want, sketch it. 1 rotation, 2nd rotation, and up to there. All right? 765 degrees. Now, let's think about it in radians. What do we do when it is in radians? Yeah?
4b, the parity rule, isn't cos
Cos minus 20?
cos minus theta should equal theta.
Yeah? But where is that will be the same as cos 210, which is in the third quadrant as well. Correct? Yeah? Okay. So the next one, how would you do it? Let's do something on the side. I'm going to show you something. Tan over 3 pi is actually 2 pi plus 4 pi over 3, correct? 10 over 3 pi is 2 pi plus 4 pi over 3. So you've done the rotation and go back again. So think about what is 4 pi over 3. And then 15 pi over 2 is actually 6 pi plus 3 pi over 2. And finally 7 pi is actually 6 pi plus pi. See, what I've done is I have actually tried to reduce it to angle that I can work on, rather than working on 10 pi, 10 over 3 pi, or minus 5 over 2 pi. That sort of stuff. So once I know that 6 pi plus 3 pi over 2 minus I am, how much have I rotated? 6 pi is 3 rotation, correct? 2 pi is 1 rotation. 6 pi is 3 rotation. Agree? 2 pi, I look at the rotation. I look at what the rotation is. So I can see that I've rotated twice. I rotated once, 360 plus 4 pi over 3. All right? This I've rotated 3 times. This one I've rotated 3 times. So therefore, we know that this is equals to 2 sine 4 pi over 3 plus 4 times cos 3 pi over 2 minus 10 pi, which will give me 2 minus square root of 3 over 2 plus 0 minus 0 equals to minus square root of 3. All right? So you must be able to think about how you do things like this. How many rotations and what quadrant it is in. All right? Next. Now, let's think about the trigonometric function. It's a periodic function. All right? The input is an angle. The angle is the domain. Then the output is a numerical value. The domain can go on 0 to 360 to 720 and so on and so forth. Or go the other way around, from 0 to minus 180 to minus 360, minus 720 and so on and so forth. So think about this, the trig function, the domain is a rotation. All right? It's not 1, 2, 3, 4, 5, 6 to infinity. The rotation is infinity in such a way that it's all in angles. All right? It's a rotation. So I could say I am rotating positive. All right. Here that will be positive. I will keep going, rotating, positive, and then back here that's 360 degrees, and I can keep going, rotating, or I can rotate backwards, which is negative degrees, and I keep rotating. So you can see that what the domain is actually the angle. Yeah? Agree? Happy with that?
Yeah.
So keep in mind for a trig function, the domain is an angle. Could be in terms of pi, could be in terms of degrees, radians of degree. So therefore, we can do y equals to sine theta, y equals to cos theta, or y equals to tan theta. All right? Now, in your handout, I have given you a worksheet. All right? Where I would like you to fill in, use your unit circle. All right? Think about the angle in radians, and then think about your cos, your sine, your tan. All right? What I like you to do is plot the, complete the table of exact values for y equals to sine x over the domain. 0 to x to 2 pi. Or 0 to 360 degrees. Plot the x values on the axis provided and sketch the sine curve. Now, try this now. I'll give you about 5 minutes to do that, and then you can do this at home. Cos x and y equals to tan x at home. And you can actually see that these are examples of periodic function. And I hope my link is still there. If I click on that, you should be able to see the graph. Possibly not. Oh, yep. Might. All right. Now you can see it's going to plot, hopefully. No, it's not. Okay. If I go, this is the cosine. When I rotate, it keeps on going. Can you see that? It just moves along. All right. If I do the sine, this is your sine rule. When I keep going, that's a sine wave. So you can see that it goes on and on. It doesn't stop. You can always experiment with this at home. And you can rotate. If I go the other way, all right. Give you a few minutes to do that. Use your unit circle to help you. Who needs a unit circle? Use that to help you. You should be able to plot sine and then try cos and tan at home. Couple more minutes, then I will go on. Now, if I go back to here, all right. Can you actually observe, is there a maximum value for the domain? Sorry, range, not domain. Is there a maximum value for the range? And a maximum value for the minimum value for the range? Yes. What is the maximum? 1. Minimum? 1. Thank you. So you can see that the domain is in terms of angles, and it goes on and on. But the range, it goes from -1 to +1. All right? So if I go on to the next one, This is another plot. You can see that the change in angle. You can see that this is actually a wave. It's periodic. It goes on and it doesn't stop at all. All right. Focus on this point, and you can see that the cos is 0 at that point. Right? Sine is 0 at that point, and cos is actually 1. All right? And then going up here, think about it, sine is, and then cos is 0, and so on and so forth. It keeps going. And for tangent, this is the same as well. The only thing with tangent is there is no tangent. There is an asymptote at 90 degrees and 270 degrees. All right. Because of the slope, at 90 degrees or 270 degrees, the slope is undefined. So therefore, there is a tangent. There is no upper or lower limit for the range of tangent theta. So y equals to tangent theta, it can go up to positive infinity and negative infinity. Now, the next thing we need to look at, the key features of the trigonometric function. So we know that if we think about things like parabola, we look at the turning point, we look at the concavity, we look at the axis of symmetry, and so on and so forth. However, for trig function or periodic function, the three key features should be equilibrium, or the middle point, the amplitude, the height of the wave from equilibrium to crown, i.e. where the equilibrium is 0 to +1 or -1 in the case of sine and cos, and period, what is the angle required before the wave repeats itself? All right, the time taken to repeat one cycle. So you can see that for sine and cos, it's actually 360 degrees or 2 pi. All right, whereas for tan it is not. We will look at it in a few seconds. So think about the three key features: equilibrium, amplitude, and period. All right? Now, look at the sine wave. What would the equilibrium be? Right? Sine wave. Let's have a look at this wave. I know it's going on and on and on. But what happened is I just taken a snapshot of it. I've taken a snapshot from 0, going up, and then turning down, and then go back to 0. All right? So the equilibrium here. Equilibrium is that, which is 0. All right? Amplitude. Amplitude is from equilibrium to the extrema. Now, amplitude, we don't have positive or negative. The amplitude is just 1. All right? The amplitude is just a magnitude. This is the same as that. There's no positive or negative. Period. What the sine take to repeat itself, the wave takes to repeat itself. So you go up, down. Here, this is not repeating itself, is it? So when you go down and go up again, the next bit, it will start repeating itself. So therefore, the period is 2 pi. Or 360 degrees, 2 pi. We're going to use radians measure at this stage, 2 pi. All right? That is the features of the sine. So you know this is the max, and this is the mean. And that is the equilibrium. All right? Now, see, it goes on and on and on. It goes on and on and on and on. And here, this is one cycle. So one period. All right? And then another period. and so on and so forth. So it starts from 0 and back to 2 pi. Or if you want to start from here, it's the same. Alright? Minus pi to plus pi, which is 2 pi. Alright, let's go to the next one. Cosine function. Now cosine function, again, looks a little bit not as easy to observe as the sine. However, if I do it that way, you can see that the equilibrium is still 1. Alright? And the amplitude maximum, max, that is still 1, gives me the amplitude, the magnitude of the amplitude is 1. Alright? And also the period from here up to here. That's 2 pi. So period is 2 pi, amplitude is 1, and equilibrium is 0. It's important for you to know the amplitude, the equilibrium and period, because when we do transformation, we will be moving the period, we will be thinking about the amplitude, and we'll be thinking about the equilibrium. And then finally, the tangent function. Now the tangent function, I've shown from 0 to 2 pi, as well as quite a bit. So you know that equilibrium, is there an equilibrium? Yes, thank you. The equilibrium is still 0. So you can see that the equilibrium, all right, is still here. The equilibrium is still here. Is there an amplitude? Why? It goes on and on and on, and it doesn't stop. So equilibrium is 0, there's no amplitude. What is the period now? Look at this. How long does it take to repeat itself? Over pi. See, if I want to do it this way, I can actually highlight that and that. From there to there, to 90 degrees, and then from just away from 90 degrees back to 180. So therefore, the period is pi. So for tangent, the period is different, is pi. Whereas for sine and cos, the period is 2 pi. Alright? There's equilibrium for tangent, but there's no equilibrium for, there's no equilibrium for, there's no amplitude for tangent. Alright, let's have a look. Something like this. Can you state the amplitude, the equilibrium, and period of the following function? We don't know what function is that. How do we determine the amplitude? Now look at the maximum point. What is the maximum point here? 0.5. What is the minimum point? Yeah? So, what would the equilibrium be? In between, oh, hang on, that's 1.5, not 0.5. My fault. That would be minus 1.5. So, between that, what is the midpoint between those two? So, max equals to 0.5, mean is minus 1.5. So, the equilibrium is actually 0.5 plus minus 1.5 divided by 2, correct? Yep. Yeah? So therefore is, what is it? 0.5. Minus 0.5. Equilibrium is minus. So that's the equilibrium point. That is your equilibrium. Alright? So equilibrium is minus 0.5. What is the amplitude then? 1, thank you. Amplitude is therefore 1. The magnitude here is minus 0.5 to 0.5, that's 1. Alright? Or minus 0.5 to 1.5, that's 1. And finally, the equilibrium, the period. Not equilibrium, the period. Alright? So think about how you could do the equilibrium. From here, if I go around, my suggestion is always look at one point. Start at one point and then trace. Repeat this, trace, and go back one cycle and it finishes at 180. So period is therefore 180 degrees minus 180 degrees is therefore 360 degrees, or actually 2 pi. Alright? Now I will use 360 degrees because here is given as degrees. Alright? That's given as degrees, so I will use degree. Alright, next one. What about this? Can you state the amplitude, equilibrium, period of the following functions? I'll let you try it first before I say anything. Yep. Sorry?
You don't have to show any working out.
Sorry? No. Okay, just working out is what is max, what is mean, what's the average. That's it. That's all the stuff. Now, generally, this is one mark question anyway. So this is a max. All right. This is my answer here. So the maximum is 3, minimum is 1. So therefore I know the equilibrium is 2. The amplitude is 3 minus 2 or 2 minus 1, that's just 1. And finally the period, I trace it. I go from this point to that point, that is actually pi. So the period is just pi. Not 2 pi in this case. Alright, the period is pi, and you know the amplitude is 1, and you can work out the equilibrium. Alright, so I've got a finished lesson here. You need to think about how I've redefined sine, cos, and tangent as a function of a unit circle. And I've showed you how to identify the periodicity of the function. So you also know how to map the revolution of a unit circle to an xy plane, where x is the argument over the extended domain. And finally, identify standard amplitude, period of the sine, cos, and tangent function.